Quality decay.
Title: Why 90% of new air conditioners are garbage. The factory secret. Before we start, if you enjoy learning the hidden truth behind everyday technology and the secrets companies don't usually talk about, make sure to subscribe to the channel and leave a like on this video. It really helps the channel grow and lets us keep making more deep dive stories like this. Now let's talk about something almost every home depends on: air conditioners. Today, modern air conditioners look more advanced than ever. They are advertised as energy efficient, quiet, and smart. Many of them even connect to your phone. But behind the sleek designs and marketing promises lies a surprising truth. A huge percentage of new air conditioners fail much sooner than older models ever did. In fact, technicians around the world often say that many modern units are built to last only a fraction of the time that systems built 20 or 30 years ago could survive. But why is that? Are manufacturers incapable of making durable machines anymore? Or is something else happening behind the scenes? To understand the situation, we need to go back in time. Decades ago, air conditioners were extremely simple machines. The core system was based on a compressor, a condenser coil, an evaporator coil, and a few mechanical controls. The designs were straightforward, and the components were often overbuilt. Engineers built systems with thicker copper tubing, stronger compressors, and fewer fragile electronics. These older units were not perfect. They consumed more electricity, and they were usually louder. But many of them had something modern units often lack: durability. It was not uncommon for air conditioners built in the 1980s or 1990s to run for 20 or even 30 years with only minor maintenance. Technicians still encounter these old systems today, quietly cooling homes decades after they were installed. So what changed? One major shift came from competition and pricing pressure. As more companies entered the air conditioning market, manufacturers were pushed to lower prices in order to stay competitive. When companies compete primarily on price, something almost always gets sacrificed: build quality. Factories began searching for ways to reduce manufacturing costs. A few cents saved on each part may not sound like much, but when you produce hundreds of thousands of units every year, those savings add up to millions of dollars. One of the most common cost reductions involved materials. Older systems used thicker copper tubing because it was strong and reliable. But copper is expensive. So manufacturers began using thinner copper lines or replacing some sections with aluminum. Aluminum is lighter and cheaper, but it is also more vulnerable to certain types of corrosion and mechanical damage. In humid or salty environments, these materials can degrade faster than the heavy copper systems used in the past. Another big change happened inside the compressor, which is essentially the heart of the air conditioner. The compressor pressurizes refrigerant and keeps the cooling cycle moving. In older systems, compressors were often built with large safety margins and heavy-duty internal components. Modern compressors, however, are often designed to be smaller and cheaper to produce. Engineers still make them functional, but they are sometimes optimized for cost and efficiency rather than long-term durability. But perhaps the biggest change came with electronics. Modern air conditioners contain circuit boards, sensors, and digital control modules. These components allow advanced features such as variable speed compressors, smart thermostats, Wi-Fi connectivity, and automated diagnostics. In theory, these features improve performance and efficiency. But electronics also introduce new points of failure. Circuit boards are sensitive to power surges, humidity, heat, and manufacturing defects. When one of these boards fails, the repair can be surprisingly expensive. In some cases, the replacement cost is so high that homeowners decide to replace the entire system instead. And that leads us to something many technicians call the replacement cycle. Years ago, manufacturers expected air conditioners to operate for decades. Today, many companies design systems around an expected life of roughly 10 to 15 years. This doesn't necessarily mean the system will break immediately after that time. But many components are optimized to last just long enough to satisfy warranty periods and typical usage. Once the system reaches the end of that design life, multiple components may begin to fail around the same time. Repairs become expensive, and replacing the entire unit often becomes the most practical option. From a business perspective, this model keeps factories busy and sales consistent. If every air conditioner lasted 30 years, manufacturers would sell far fewer new units. Another factor that changed the industry was government efficiency regulations. Many countries introduced strict energy efficiency standards for cooling equipment. These rules were created with good intentions, reducing electricity consumption and lowering carbon emissions. To meet these standards, manufacturers redesigned many systems to maximize efficiency. That often means using more complex compressors, additional sensors, and advanced electronic controls. While these designs can reduce energy consumption, they also make systems more complicated and sometimes more delicate. There is also the issue of refrigerants. Over the years, several older refrigerants were phased out because they harmed the ozone layer or contributed heavily to global warming. Each time a new refrigerant was introduced, manufacturers had to redesign their equipment to handle different pressures and properties. Some of these transitions happened very quickly, forcing factories to rapidly adjust their designs. In the process, some systems became more sensitive to installation quality and maintenance practices. And that brings us to another hidden secret. Installation quality matters more than most people realize. Even the best air conditioner can fail early if it is installed incorrectly. Poor refrigerant charging, improper airflow, or badly connected electrical wiring can shorten the lifespan of a system dramatically. Unfortunately, installation standards vary widely. In many markets, contractors are under pressure to install systems quickly and cheaply. When shortcuts are taken during installation, the system may develop problems years earlier than expected. But there is another reality that rarely appears in advertisements. Many manufacturers now design their products with serviceability limitations. In other words, certain components are difficult or expensive to repair. Instead of replacing a small part, technicians sometimes must replace entire modules or assemblies. This approach simplifies manufacturing, but increases repair costs for consumers. For example, a failed sensor or control chip might require replacing an entire control board. And if that board costs hundreds of dollars, the repair bill can quickly become painful. So does this mean every modern air conditioner is terrible? Not necessarily. There are still manufacturers producing high-quality systems, and many modern units perform extremely well when properly installed and maintained. However, consumers often choose equipment based only on the lowest price. When cheaper models dominate the market, manufacturers naturally focus on reducing production costs to remain competitive. In other words, the market often rewards cheaper machines rather than longer-lasting ones. Maintenance also plays a huge role. Air conditioners work in harsh environments. They deal with heat, dust, humidity, and constant vibration. Without regular maintenance, even the best systems will struggle. Simple tasks such as cleaning coils, replacing filters, and checking refrigerant levels can extend the life of a system significantly. Technicians frequently say that a well-maintained air conditioner can last twice as long as a neglected one. So what can homeowners actually do to avoid buying a poor quality system? First, research brands carefully and read long-term reliability reports rather than just marketing claims. Second, focus on the installer just as much as the equipment. A skilled installer can make a huge difference in system performance and longevity. Third, consider simplicity. Sometimes a slightly less complex system with fewer electronic features can be more reliable over the long run. And finally, maintain the system regularly. Annual inspections and cleaning can prevent small issues from turning into expensive failures. In the end, the truth about modern air conditioners is not as simple as saying they are all garbage. The reality is more complicated. Factories balance cost, efficiency regulations, market competition, and consumer expectations. These pressures shape the designs we see in stores today. But by understanding how these systems are built and why certain compromises exist, consumers can make smarter decisions and avoid many of the problems that lead to early failures. So the next time you see an advertisement for the latest revolutionary air conditioner, remember that the real story often lies behind the factory doors. And if you enjoyed this deep dive into the hidden side of modern technology, don't forget to subscribe and leave a like. It helps the channel more than you might think, and it tells us that you want to see more investigations just like this one. Thanks for watching, and we'll see you in the next video.